Take a moment. Look around you. That pen lying on your desk? It's a solid. The water you're sipping? That's a liquid. And the steam gently rising from your tea? Definitely a gas. We see these forms of matter every day, but have you ever wondered what makes them different? It all comes down to how their tiny particles are arranged, spaced, and move. In this video, let's break down the three states of matter: solids, liquids, and gases. Let's kick things off with the solid state. Solids are materials that have a definite shape, a fixed volume, and strong forces of attraction between their particles. Here's a simple activity: pick up a pen, a book, or a wooden stick. Now trace their shapes. You'll see that their shape doesn't change. That's the nature of solids. But let's take it a step further. A rubber band stretches but returns to its original shape. Sugar crystals fit into any jar, but each crystal still has its own structure. A sponge compresses, yet it comes back to form. Why? Because in all of these, the particles are tightly packed, with very little space between them. Even when they seem soft or flexible, at the microscopic level, they're behaving just like solids. Now let's dive into the liquid state. Liquids don't have a fixed shape, but they do have a fixed volume. They flow and adapt to the shape of any container they're in. Try this simple activity: pour milk, water, and oil into containers of different shapes. Notice something? The shape changes, but the amount stays the same. That's because the particles in liquids are loosely packed. They have more space than solids and can slide past each other. This gives liquids their ability to flow smoothly. And there's more: liquids can diffuse faster than solids. For example, oxygen and carbon dioxide dissolve in water, allowing fish and aquatic plants to survive. So, the behavior of liquids is all about freedom of movement without losing volume. Let's move to the most free and fast-moving state of matter: gases. Gases have no fixed shape and no fixed volume. They expand to fill the entire space available to them. Ever watched a single gas cylinder inflate dozens of balloons? That's because gases are highly compressible. They can be squeezed into small spaces and then released to expand freely. Here's an activity. Try pushing the piston of an empty syringe filled with air. Easy, right? Now try it with water or powdered chalk. Much harder. Why? Because gas particles are widely spaced, with very weak attraction between them. They move rapidly in all directions, which is why the aroma of hot food spreads across a room within seconds. Gases are truly the most dynamic and expansive form of matter. Now that we've explored each state individually, let's place them side by side to really see the difference. Pretty neat, right? Now, let's connect this to the real world. Solids, like furniture, tools, and buildings, are rigid because their particles are tightly held. Liquids, such as drinks, oil, and even blood, flow easily but keep their volume. Gases, like air, steam, and oxygen, move freely and fill every corner of the space they're in. So, what makes each state behave differently? It's all about how the particles are arranged, how much space is between them, and how strongly they attract each other. Let's try a simple yet powerful activity straight from your textbook, and it answers a fascinating question: why does a gas fill an entire container but a solid doesn't? Here's what you'll need. Take 3 100ml syringes and seal the tips using rubber corks. Now, prepare the test. Leave one syringe empty. It's filled with air. Fill the second with water, and the third with chalk pieces. Reinsert the pistons, maybe apply a little waistline for smooth movement, and now try to push them in. The syringe with air? compresses easily. The one with water resists, but you can press it slightly. And the one with chalk, no movement at all. Why is that? Because gases have particles that are far apart and free to move, so they compress easily. Liquids have particles that are closer, making them slightly compressible. And solids? Their particles are tightly packed, leaving no room to compress. Conclusion: the ability of a substance to compress or not depends entirely on the spacing and movement of its particles. That's why gases fill any container, while solids hold their shape no matter what you put them in. Let's wrap up what we've learned. Solids' particles are tightly packed, giving them a fixed shape and volume. Liquids' particles are loosely packed, so they flow and take the shape of the container but still have fixed volume. Gases' particles move freely with no fixed shape or volume. They spread out to fill any space. And what causes these differences? It's all about how particles are arranged, how much space is between them, and how strongly they attract one another. In our next video, we'll explore something even cooler: how matter changes from one state to another using just heat or pressure. Stay tuned.